Welcome to Lesson 3 of Module 2 on Introduction to Databases and Database Management Systems. I'm going to start with a very simple question that I want you to think about throughout this lesson. How does a DBMS differ from desktop software such as spreadsheet or word processor? Everyone should be familiar with using standard desktop software, but most of you are not familiar with DBMS software, even though a DBMS is often part of a desktop suite or at least an extended desktop suite. You have 3 objectives in this lesson today. In your own words, I want you to briefly explain what a DBMS is and typical DBMS product variations. I want you to be able to explain to a friend familiar with desktop software but not a DBMS the essential difference between a DBMS and other standard desktop software and how the software is used. A database management system, or DBMS, is a collection of components that supports the creation, use, and maintenance of databases. Initially, DBMSs provided efficient storage and retrieval of data. Due to marketplace demands and product innovation, DBMSs have evolved to provide a broad range of features for data acquisition, storage, dissemination, maintenance, retrieval, and formatting. The evolution of these features has made DBMSs rather complex. It can take years of study and use to master a particular DBMS. Because DBMSs continue to evolve, you must continually update your knowledge. Enterprise DBMSs use servers running Unix, IBM's MVS operating system, and Microsoft Windows Server operating systems. The Unix and Windows Server environments dominate enterprise DBMS sales, with IBM mainframe environments having a much smaller market share. Enterprise product versions support organizations with large databases, thousands of simultaneous users, and strong reliability and performance requirements. Oracle is considered the leading provider of enterprise database products, with strong competition, though, from IBM, Microsoft, SAP, Teradata, and open source products such as MySQL. Desktop database versions support small workgroups with smaller databases, tens of simultaneous users, and modest reliability and performance requirements. In the market for desktop database software, Microsoft Access dominates, at least in part because of the dominance of Microsoft Office. Because of the potential growth of personal and mobile computing devices, most major DBMS vendors have now entered the embedded DBMS market. Embedded DBMS software is primarily sold by value-added software resellers as part of an application, such as an accounting package. Thus, embedded DBMSs are hidden from users and require little or no ongoing maintenance. Database definition is the feature that distinguishes standard desktop software, such as word processing and spreadsheets, from database software. When developing a document or spreadsheet, little or no planning is required. As a document or spreadsheet develops, styles and formulas can be added to provide dynamic planning for the entire document or spreadsheet. In contrast, planning is essential for databases, even for small workgroup databases. A diagram showing the types of entities and relationships should be developed to support the intended usage of the database before a database can be implemented. We will be working with databases that contain tables and connections or relationships among tables. DBMSs provide several tools to plan and create databases. The structured query language, known as SQL, provides the create table statement to define tables and relationships using a structured computer language. SQL provides a loose standard for the entire database software industry. We will see details about the create table statement in Module 3, enough details that you can use the statement to create tables. DBMSs typically provide graphical tools to augment the create table statement. These tools, although not portable across the database software industry, are much easier to use. They can be used to create diagrams that can be more easily communicated than SQL statements. To show proprietary details of database definition, I want to talk about an Oracle database diagram. The details are not important for this lesson. I will provide details in Module 3 so that you can understand the meaning of the diagram. The important point for this lesson is that the diagram provides a visual representation of the interrelated characteristic of databases, showing the types of entities, courses, faculty, offerings of a course, students and enrollment, and relationships among the types of entities. Students make enrollments in courses taught by faculty. You will learn the meaning of the abbreviations and symbols in this diagram in Module 3. Now I also want to show a similar database diagram for the same university database, except that the diagram is part of Microsoft Access desktop database software. The details are not important for this lesson. Since this course will not cover Microsoft Access, I will not explain the meaning of the symbols in a diagram in a later lesson. The important point for this lesson is that the database diagram provides a visual representation of the interrelated characteristics of databases. These diagrams are not standard across database products like the SQL create table statement. For most commercial database products, an important feature will be a graphical tool to plan the types of information and the relationships in a database. I want to reiterate the point that I've made in previous lessons that databases and database technology are vital to modern organizations, supporting both the daily operations and decision-making. The distinguishing feature of database software from standard desktop software is the need to define and plan the details of a database before building and using a database. Although the structure of a database can be refined after deployment, the initial planning is essential and often laborious. The success of a database is contingent on the level of planning and design before the database is deployed. To demonstrate your understanding of this lesson, you should try explaining the essential difference in a DBMS as compared to standard desktop software to a friend. DBMSs are complex software with many features. This lesson is focused on the important feature of database definition. You can devote years of study to a particular DBMS to understand a range of its features. This complexity provides strong employment opportunities for you both to master a subset of features, apply your knowledge to assist colleagues, and accomplish database development tasks, and then continue in your education as the DBMS product evolves. The next lesson focuses on another crucial feature of a DBMS, non-procedural access. As you will see, non-procedural access has been critical to improvement in productivity to develop software applications. The massive growth of the software industry, including the burgeoning app industry, is partially due to the important feature of non-procedural database access.